We'll just wait for we'll just wait for 1 more minute and then we'll start. We'll wait for people to join in. Okay, so we'll start now. So today we are covering the topic CRUD applications in Flutter, and we'll be using Cloud Firestore for that. I request Dhruv to make the presentation. Yeah. So we'll be discussing about the CRUD application in Flutter, and we'll be using Firestore for that. So Firebase has this feature called Cloud Firestore, in which we can store the data in document relations, unlike previously in real time that we used to store in like a JSON format. So we'll be using Cloud Firestore for today. So what we'll be learning is all the CRUD operations. So create, read, update, and delete. So Firebase allows us to handle all these four operations using its SDK, and we'll be integrating it in Flutter. So the create is, if you're not familiar, the create is if you want to add a non-existing data in the database, use the create function. The read is to fetch the data, the get request, as you know in the backend API, if you have seen the earlier session. The update is to modify an existing data in the backend, and delete is, as the name suggests, it is to remove the data from the backend. So the Cloud Firestore has the document relations database, which will allow us to store data in form of collection and documents and then feeds. So we'll see. I'll show you later what exactly it looks like, the visual representation of the Cloud Firestore. So Cloud Firestore is a flexible, scalable database for mobile web and server development from Firebase and Google Cloud. And it is a cloud-hosted NoSQL database that your Apple, Android, and web apps can access directly via native SDKs. So what Firebase does is it allows us to use this SDK and integrate in our native apps, and so that we can connect it through the app to the data that is on the cloud. Another thing you'll see while integrating Firebase with Flutter or with any native SDK is that you'll be given a Google services.json file. So what this file actually contains, it is what actually connects your Firebase to your app. So the file contains all the API keys, the package name of your app, all the necessary data it needs to know which project your app is connected to in the Firebase. This file is also responsible for all the this file is also responsible for all the security, not all the security, but it is like kind of a very sensitive file. So it is usually not suggested to push it on the GitHub or wherever you're hosting your repository, because once you do that, all the sensitive data can be accessed through the API keys as well as the package name. So Firebase actually allows us to use a lot of different features. We'll be comparing two of them, the real-time database and the Cloud Firestore. So what the real-time database does is it stores all of your data in one JSON tree. So suppose you have created an app and 10 people download it. So all of their data, if they push it using the create function, so if they do that, all of will be stored in one large JSON tree. So like if the data is very simple, it is easy to store because it is just one JSON file. So you don't need to maintain a lot of files or collections for that. But again, if you have a lot of data and a lot of people have downloaded your apps, it will become very, very tiring to find data or to even visual visually see that. So we for that we can use Cloud Firestore instead. So Cloud Firestore, what it does is instead of storing it as a JSON document or a JSON tree, it stores as a collection of documents. So you can have several collections as well for one project. So suppose you want to store the list of suppose announcements on the app, or suppose you want to store the list of all the events that are going to you're going to show on the app. So what you can do is make a collection named events, and in that you can make all the different events as a document, and each document uh, a detail as a field of that document. So this hierarchy is followed in Cloud Firestore. So by this method, you can easily store complex and hierarchical data because it does follow an hierarchy that is easy to see and easy to navigate through. So to install it, you can use the cloud underscore Firestore package uh, while developing your Flutter app. You can get it on the official pub.dev website. So now we'll be going in more into detail about how to write data, and we'll be seeing a block of codes for that. So the first of the CRUD function is create, that is write. So what this is doing is, as you can see in the first line, we have made a collection of cities called cities. So what we are doing is DB means the database, and we want the cities collection to be initiated in this variable called city. Now what we want is in the cities collection, we have made a mapping here, as you can see, name, state, country, capital, population, and regions. So we have made this as data one, and we use the set function to write data in Firebase. So this set function is very important, and you must remember that while writing data, we use set, not create or write. So in the last line, you'll see that cities.doc sf.set data one. So in here, as I said earlier, there were three hierarchical things: the collection, the document, and the feeds. So as you can see here, we have initialized the collection, and then we are telling the Firebase, the Firestore, the collection, the document name is SF. As you can see, doc SF. So cities is the collection, and SF is the document, and then data one has all the fields. So collection, document, and fields. Collection, document, and fields. So this is how you write data. This is just a very basic block of code. Now, how to read data. So suppose you have your data as we just wrote it in the previous slide here. Suppose you have written data on the Firebase. Now we want to fetch it. So what you can do is first of all, you need a reference of the collection or the document. What you can also do is instead of referring a single document, you can also get all the documents of a particular collection. So here we have referenced a document. So in this, we want the document is stored in the collection called cities. So we have written dot collection cities dot doc sf, and DB is your database that you have initialized uh, earlier using the Firestore dot initialization. So now dot doc ref dot get then. So what this dot get does is, as you can see in the previous slide, it was dot set. In the last line, you can see it is dot set data one, but here it is dot get. So this get function fetches the data, and then as soon as we have a response, it could be either a successful response or a response with an error. So as soon as we get it, the then block is implemented, And if we have got the data, we will, what we are also call the data is called document snapshot. So here, as you can see, once we have got the data, we are referencing it as a document snapshot. This document snapshot is defined in the packages that we will install while making the app. The packages from Firebase. So here you can see this document snapshot, and we have named this as doc. So if we get a successful response, so we ask we write a line like this: data is equal to doc.data, and as map string slash dynamic, string comma dynamic. As you can see in the previous slide, here we have used the same thing, string comma dynamic, if you can see in the second line. So that's what we are fetching here. On the other hand, if we face any error, we'll catch that error and print the error for using the same line. Now, suppose there are two ways to fetch data from Firebase. So suppose there you have a limit. Firebase, what Firebase actually does is you have a limited number of reads writes from the Firebase. So instead of calling every time from the server, you can also call it from cache. So what it does is the Firebase SDK allows you to fetch the data from the cache itself, and the best part is you don't have to cache it. The Firebase SDK does the caching itself. You just need to mention the source. So in this slide, as you can see, the first line is same as the previous slide: db.collection cities.docsf. So in this slide, what is happening is we first wrote the document reference similar to the earlier slide, but then we'll mention the source. So here we have mentioned source.cache, but if you want to call it from a server, you can just write it as source.server. So what you can do is, once you are calling, as you can see in here, the brackets of the get were empty, but here you can pass this parameter source. So the function will know where to fetch it from, and it will do that accordingly as you have mentioned it. So the benefit of using this is, suppose you have a lot of downloads for your app, but you still have a Firebase limit for which you need to pay if you have a lot of users. So what cache will do is, if you mention that, suppose every 6 hours, only every 6 hours we'll call from server, other times we'll call from cache. So the number of reads reduces drastically. So this function actually does help a lot in production apps. Now the third CRUD function is the update function. So here, as you can see, we have stored in the right one, we have stored a field called capital, and we have written mentioned it as false. But suppose we want to make it as true. Suppose we are updating the value. So what we can do is, we'll just write it as, first we reference the document. So in suppose this time the document name is DC. So the data should be existing. This field should be existing, and it should be of the same data type the earlier value was. So in this case, Boolean. So we'll just write Washington reference dot update capital, and then we'll pass the values. You can pass several values. Suppose you want to update the name. So after true, you can put comma and then name, and then pass the updated value. And then once it is done, it will get a response if it is updated or not. If we have got it, you can just print it, or you can do any other function that you want to do once it is updated to show a toast message to the user. Otherwise, you can handle the error the same way we have handled errors earlier. So the last CRUD function is delete. It is db dot collection cities. First, we'll reference the document and then delete. So in this case, we are deleting the entire document. We are not deleting the collection cities or a specific field. In this block, you can see it is printed also document deleted. So this is how a basic the basics of the CRUD function using Flutter and Firebase. So now I'll show you some code so that you can actually understand what happens when we do that. Just a second, I'll share my screen. Yeah, so sorry for that. Uh, so this is a visual representation of a Cloud Firestore. So on the left hand side, as you can see, uh, there's a collection, and in the middle we have documents, and on the right we have fields. So one collection can have several documents, and one document can have several fields. So these fields belong to this document. This is the document ID. You can also put your custom document name or IDs if you want, and you can also have several collections in for one project. So we have for in this project grounds and slots, and in this we have two documents, and we have mentioned two ground names. So one is an international an international stadium in Mumbai, and the other is another stadium in Delhi. So what we'll be doing today is we'll be fetching these data to show in our Firebase app. Today I'll just code the specific lines to show you how to integrate the collection and then reference the document from that. Yeah. So here I've written the basic UI for this. Now we'll be using the documentation to write the code for this. So as you can see, I'll just go through the code once. I've already put the Google services.json file here that you get once you install it. The error is because we have commented out some lines that we'll be filling today. So in this, uh, as you can see, it is a single child scroll view, and we have a column here, and we'll be using Stream Builder today. So here we need to mention which collection we want to access, and then we'll be initializing the data. And if we want to have a name for the data so that it is easier to pass it to the sub widgets, so we'll do that. And then you can pass the name, the location, and the pitch type as uh, mentioned in the Firebase collection. Just a second. Yeah. So you can start. So in this, we want to tell the app which collection we want to use. So as you saw in the Firebase Firestore, we were using grounds collection. So we'll be using that. And as you can see, we have another statement which I'll show you just in a second. So first, what we are doing is, uh, till here, what is happening is we are referencing the grounds collection. But suppose you just want a specific some condition to pass through so that the Firebase sends you the filtered list. So what is happening here is, um, what it is doing is, it is seeing the date parameter in the grounds field, and then if the date is equal to the current date that I've mentioned using date time down to string and then substring 0 to 10. So if that is same as today's date, then it will pass the snapshot value to the UI, otherwise it will not. So you'll see in the app once I run it what I'm actually talking about. Here we need to pass the data to the list view. So what we'll do is we'll do snapshot.data and document snapshot. As you saw in the slides, I referred the document snapshot data type. That was all that we have not defined, and it is coming from the package. As you can see here, package cloud underscore firestore. So it is defined in the package itself. So now we'll be giving a name to the data. We'll call it just data so that it is easier to pass. So we'll be using data as a name. You can put it as anything, suppose the GDSE. So here we need to pass GDSE here because this data contains all the fields that is mentioned in the Firestore. So we'll do GDSE and then the name of the field. So I'll put name and then GDSE. What we need to pass is here is the location, right? So we'll put location. And here we need to pass the pitch type. So we'll just write GDSE pitch type. So I'll just run this. We'll handle the errors on the way if we have any. This should be done within a minute. I'll request I'll request Zoom to put my video on the left side. Yeah. So as you can see here, uh, for this we have got no field values. We'll just see in the app what is happening. And okay, so in the Firestore, actually the date is not mentioned here. I'll just fix it in a second. Until then, just restart my Android Studio as well. Just a second. I'll just restart it again. There are some issues with the Firebase. Yeah, so I just my Andy Studio is now open. You can see. Yeah. So now we'll run the app, and as I've mentioned in the earlier thing, that what we actually did is we named three things: the name, location, and pitch type. In this case, what we, the Firestore also had a lot of other stuff in other fields. So this UI actually implements all of them. It is a working example to fetch the list, fetch the all of the data that we saw in the Firestore, which I'll show you again once more. So first I'll run this. Okay. Yeah. So if you can see, we have here the Jawaharlal Nehru Stadium, and on in the Firestore we only had two things. One was for April 7 and one was for April 8. So here on April 7th we have Jawaharlal Nehru Stadium, and here we have another stadium. So for this, you can mention all of the stadiums you want to show. You can even show a lot of stadiums in one date as well. I'll show you if we want to show this stadium in April 7, what we can do. So I'll share my entire screen for now, and then we'll also go through some documentation to see what other things we can also do with this. So yeah, I'm sharing my entire screen now. Yeah. So here, as you can see, what we first did was we want this thing to be shown under April 7th. And suppose we also want to change the name or something. So we'll just go to this thing and change the date parameter. So here it is April 8. We'll just put it as 7. And inside name, we'll put it as GDSC VIT. So once we go to the app, as you can see, April 8, there are no grounds. And if we go to April 7, we have got GDSC VIT and the other stadium right here. So this is how you can fetch from Firebase. What I also wanted to talk about was the other features. As you saw here, we have used only the in this page we have used only the stadiums that have date as April 7th. So you can also pass a lot of other parameters while fetching data. So if you are fetching data, first we'll just see the official documentation for how you can pass other parameters. There are a lot of parameters so that you can filter the data while fetching. So there's a function called count. So you can count all of the data for while fetching. As you can see, we have used exactly this. Our data was named GDSE, but here in this official example, we have used data itself, and we have also passed the name parameter, and we had a parameter called location and pitch type. So in this, you can see we have a lot of other parameters as well. We have a parameter called image. So this image link loads the image right here. Yeah, I guess that's it. I covered all the CRUD functions. So that was the CRUD function using Firebase, and we showed you a working example of of an app. So thank you for joining, everyone. Hopefully, we'll conduct more sessions with uh, many other features, not necessarily Flutter, but other things as well, like website and backend. Thank you.